Adempanya with your wonderful lesson on summarizing. Now you've made me to summarize my lesson also. Good afternoon, everyone. The Theorem of Pythagoras, we are now doing lesson 3. I'm your presenter, Mr. Guma MT from Feziletabi. Let us move on. I will never do anything without describing it. What is a theorem? I'm repeating this so that it is drilled into your heads. A theorem can be defined as a rule, principle, or statement that can be proved to be true. When we are talking about the theorem in mathematics, we are actually referring to this, my friends. Now, moving on, I hope that now it is in your heads, and I know that some of you will actually give me the name theorem. It's fine. Now we move to the core business of the day. Theorem of Pythagoras. We know what the theorem is now. A statement or a principle that can be proved to be true in mathematics. Now, what does this theorem tells us? The theorem of Pythagoras states that in a right-angled triangle, friends, please now, note this, it is very important. Not in any other triangle, but specifically the right-angled triangle. The square of the hypotenuse is equal to the sum of the squares of the other two sides. That is very important. I'm going to take you through this mathematically now so that we understand it. Now, Pythagoras' theorem in a mathematical form. There we have a right-angled triangle. What is a right-angled triangle? Any triangle that has one of its angles which are equal to 90 degrees. That is a right-angled triangle. Look at that. Angle PQ, triangle PQR, with angle Q, which is equal to 90 degrees. Now that says to us that triangle is a right-angled triangle, okay? Now it means that the theorem of Pythagoras can be applied in this case. Now, let us look at this triangle. If I tell you that the side PR has the length small q units, and the side QR has the length small p units. Now, if you look at what we did here, small q units is the side which is opposite the 90 degrees angle. Opposite, I mean that there's 90 degrees angle, there's PR, which is small q. And if you look at small p, which is QR, it is actually opposite that angle. All right? Now, if we tell you that PQ is small r, that means it is opposite angle r. Now, the theorem says the square of the hypotenuse is equal to the sum of the squares of the other two sides. Now, who is the hypotenuse? It is PR, which is small q squared. Let's look at this mathematically. Now, small q squared is equal to small p squared plus small r squared. There is my reason. Never forget to give us that reason. The theorem of Pythagoras. That was Pythagoras' theorem in a mathematical form. Now, moving on. The theorem of Pythagoras in calculations. Folks, we will expect you to calculate the length of an unknown side if we give you a right-angled triangle with two sides known to you. Now, again, we will expect you to prove that a triangle that was not said to be right-angled triangle is actually a right-angled triangle using what? All the three measurements that we shall have given you. Let's go through this one. There is triangle PQS now. And we tell you that PS is actually 4 root of 2. PQ is 2 root of 2. And QS is 2 root of 6. Now, we want to know what type of a triangle is triangle PQS. And you must show with calculations. We did not say it is a right angle triangle. We want to know from you what type of a triangle it is. Now, looking at that angle, it can be 90 degrees. And looking at this one, it can be 90 degrees. But looking at that one, I suspect that angle Q might be 90 degrees. Now, my first question is PS squared equals to PQ squared plus QS squared? Is this side, which is opposite the angle that I suspect to be 90 degrees, equals to the sum of the squares of the other two sides? Now, that is the question I'm asking myself. Now, I'm going to prove this. PS squared is said to be 4 square root of 2. Now, PS squared would be 4 square root of 2 all squared. When I simplify that, 4 squared is 16. Square root 2 squared is 2, and 2 times 16 is 32. Now, I know that PS squared is 32 there. If these two can add up to 32, I would say this is a right angle triangle. Let's see what happens with them. Now, I'm taking PQ squared plus QS squared. And PQ is 2 root of 2. Now, PQ squared would be 2 root 2 all squared. QS is 2 root of 6. Now, QS squared would be 2 root 6 all squared. Remember, I don't know whether those are equal or not. I'm proving. I cannot say they are equal before I prove them to be equal. Now, when we simplify those two brackets, this is what we get. 2 root of 2 all squared is 8. And 2 root of 6 squared is 24. And of course, 24 plus 8 is 32. What can we see here? This side is 32, and this side is 32. Now, it means that this triangle is actually obeying the theorem of Pythagoras. I so love this now. When all things are coming together and working all, okay, now I can say that triangle PQS is a right angle triangle with angle Q that is equals to 90 degrees. And how do I know? Because the square of that side, which is opposite to that angle, is actually equals to the sum of the squares of the other two sides. Remember, if this is 90, that side is the hypotenuse. Now, it means that we have proved that angle Q is equal to 90 degrees, folks. I'm so happy that this worked out for you. Now, we can put a 90 degrees there and say, hey, angle Q, you are 90 degrees. Let's move on. The next one, that is now Theorem of Pythagoras integrated into other shapes. Look at that. We have a rectangle ABEF. That's beautiful. And we have triangle BFC there. Look at that angle. Triangle BFC is actually a right angled triangle. And we have got triangle AED with angle E, which is equal to 90 degrees. Folks, once you see a triangle and a 90 degrees angle, just say, hallelujah, we are going to use the theorem of Pythagoras. But now let's go through the question first. Calculate the perimeter of a trapezium. The whole shape ADE ABCB is actually a trapezium which has got those two right-angled triangles. Now, for 5 marks, we are going to do this. But first of all, what does the examiner want? The examiner wants the perimeter. And what is the perimeter? The perimeter is sum of all the sides of a closed polygon. Now, it means for us to find the perimeter, we need to know the length of this side. We need to know the length of this side. We need to know that length. We need to know that length. The polygon is closed. But now we are in trouble because we don't know BC. We don't know AD. Now, is that a problem? Never, because we know these two sides in this right angle triangle, and we know if AEFB is actually a rectangle, we know this side and this side. Now, step number 2. What type of triangles are ADE and triangle BFC? We have said that, we have seen them, that they are right angle triangles. Step number 3, if they are right angle triangles, apply the theorem of Pythagoras to calculate the sides that we need to know. We need to know AD, we need to know BC. Now, let's move on with this. My friends, I'm going to pin it there so that as I'm moving on, you see what is actually happening. I'm now going to try and find AD. I'm going to say in triangle ADE. I'm telling everyone now, I want Mr. Potgieter to know where I'm working. I'm working in triangle ADE, oh boy. Now, I can apply the theorem of Pythagoras. Why? Because that triangle is a right angle triangle. Now, the theorem of Pythagoras says the square of the hypotenuse, which is the side opposite the 90 degrees angle there, is equals to the sum of the squares of the other two sides. There, I did that. And don't forget the reason, please. Now we substitute. AD squared is equals to 5 squared. And remember, this is equals to that in a rectangle. And AE squared is 9 squared. Then we go on and simplify. 5 squared means 5 times 5, which is 25. 9 squared means 9 times 9, which is 81. Then we add the 2. AD squared is now 106. We are not looking for AD squared, we are looking for AD. Now, we are going to find the square roots of both sides. Remember what Jesus said. What you do on the left-hand side, you must also do on the right-hand side. Amen into that. The square root of AD squared is 80. The square root of 106 is 10.3. And the SI units were meters. That means that side is 10.3 meters. I hope everyone is happy. Now, we've got 1, 2, 3 sides. We are only left with that one to find so that we score the 5 marks. Now, let's find that side. In triangle BFC, now there's triangle BFC. Why am I telling? It is because I've got how many triangles? 2 triangles. Now, I want you to know where I'm working from. It is a right angle triangle, of course. The square of the hypotenuse, which is the side opposite the 90 degrees angle, is equal to the sum of the squares of the other 2 sides. Do you see how beautiful it is when you know and understand the theorem? As you are applying, you are singing it into yourself. Good. We substitute. BF squared, in this case, is it BF? No, it is BC squared. I'm sorry. Not BF squared, but BC squared, which is the hypotenuse there, is equal to 9 squared. And the 9 is there. I put it there. And FC squared is 8 squared. There's your 8 squared. We simplify. 9 times 9 is 81. 8 times 8 is 64. And we add the 2, we get 145. And now we find the square root of both sides. Folks, remember, we are finding BC, the naughty F. I don't know what it is doing there. Now, BC squared is actually BC, not BF. And the square root of 145 is 12,04 meters. Now, with this information, I know this side. And I know this side. I can actually add this side plus this side plus this side plus this whole side, which is 20 plus 8 and 5 meters, to get the perimeter that the examiner wanted. And I take my 5 marks and run home with it. I hope that, folks, you understand the theorem of Pythagoras and you know what the theorem is, and you actually know when to apply the theorem of Pythagoras and how. Remember, I said we can require you to prove that a triangle is a right angle triangle. We shall give you all the 3 sides. You will have to suspect that one angle is 90 degrees so that you can be able to say, maybe my hypotenuse is this. Number 2, if we tell you that it is a right-angled triangle, then you just go and fetch the theorem of Pythagoras from your mathematical tools and use it to fix whatever that we want you to fix. Folks, this was our last lesson for the year. I hope that you shall enjoy your exam and nail them. Having said that, here's your QR code for practice questions. For those of you who can scan, you will scan the QR code and practice. For those of you who want to use your link, you can actually get the link there and use it to practice. Mr. Hlaba will get in now just after me with his wonderful EMS.
Yes, Meneer.
Mr. Potgieter, thank you so much for the opportunity. It is my
yes,
last
Meneer.
lesson and all my colleagues.
Yeah, just a moment. I'm trying to connect with the laptop because this one is a phone.
Okay, that's fine. We'll wait for you. Thank you very much, Mr. Banya. We appreciate it. Mr. Guma, we appreciate your lesson.